consumers in the options. Let's look at this. So the answer here is B. Why? So let's look at general formula of different compounds. Firstly, let's look at alkanes. Alkanes have the formula CnH2n plus 2. These are alkanes. Alkenes are CnH2n. Okay. Now, why alkynes is CnH2n minus 2. Now, why alkyl halides are CnH2n, okay, plus 1, and then X, where X represents the halide. The halide can be a chlorine group, that's basically halogens. It can be a bromine group, it can be fluorine or iodine. Now, another formula, compound, let's look at ethanol. Have the general formula CnH2n plus 1 OH, while carboxylic acid has the general formula CnH2n plus 1, then the functional group COOH. So these are the general formula of some organic compounds. So take note. So let's go to the next question. Okay, which of the following type of reactions takes place between ethene and halogens? Now, this is an ethene, this is an alkene. So take note of this. Alkene plus halogens is additional reaction. Now, why alkane plus halogen will give us substitution reaction. So our answer here is addition reaction because this compound is an alkane. So let's go to the next question. The IUPAC name of the compound above is, okay, there's an error here. Let's do this now. The first thing is your numbering. So when you number so as the functional group or the substituents will have the lowest number as possible. So I'm going to number from the right. So this is 1, this is carbon 2, this is carbon 3, and this is carbon 4. So when writing the name of your organic compound, you first of all write the name of the substituent. So the substituents here we have this and this, okay, and they are located on the third carbon. So this becomes 3. So since there are 2, we use di to tell us that we have 2 of the substituents, which is methyl. And then after naming all the substituents, you can now write the name of the main chain. Now the main chain has 4 carbons, so it is bots. So since it has a double bond, it's going to be bots1-ene. It's an alkene compound. So bots1-ene. 1 because the double bond belongs to the first carbon. Yeah, you might say that, but the double bond is between the first and the second carbon. So why didn't we give it to, why don't you write 2? Okay, we can't write 2 because we have to give the double bonds to the lower carbon, so which is carbon 1. So that's why it's bots1-ene. The compounds made up of only carbon and hydrogens are called hydrocarbons. That's a very simple one, hydrocarbon. So let's look at the next question. So, all right, let's see how we can name this organic compound. The IUPAC nomenclature of the structure is, the first thing you have to do is the numbering. So I would number, like I told you, number so that the substituents would have the lowest number. If I number from my right, 1, 2, 3, my substituent is going to be on the third carbon. But if I number from my left, 1, 2, 3, 4, the substituent is going to be on the second carbon. So the correct numbering is from the left. So now let's name the substituents, which is, we have chloro, and then we have methyl. Okay, so since we have 2 substituents, okay, located on the second carbon, you have to name the substituents alphabetically. So C comes before M. So this is 2-chloro, 2-methyl. So all right. So after naming the substituents, now let's name the main chain or the root chain. So the main chain has 4 carbon. Okay, so it becomes a bot. Now since it's a single bond, it's going to be butane. So we have 2-chloro, 2-methyl butane. So the answer there is D. All right. Which of the following represents ethyl ethanoate? Okay, now. So ethyl. Now this is called, this is an ester actually. Ethyl ethanoate is an ester. So to name an ester, ester has 2 parts. It has the alkyl part and it has the alkanoate part. So the first part you will write is the ethanoate. Ethanoate, from the word eth has 2 carbons. So it is CH3, CH, okay, it's eth, okay, COO, okay. So, and then ethyl. Ethyl means there's 2 carbon. So we have CH2 and then CH3. So this is alkyl alkanoate. That's ethyl ethanoate. So now let's look at which of them corresponds to our. So we have this is not it. This is not it. This is wrong. Okay, this is correct. So the answer is D. So if you look at it, it corresponds to our answer. So now the next one, next number. So which of the following organic compound will decolorize bromine water? So compounds that usually decolorize bromine water are compounds that have double bonds. So because this is test for unsaturation, because double bonds signify unsaturation. So if you look at the option, this has a single bond, this has a single bond, this has a single bond. So the only double bond is benzene. So another compound that actually exhibits this is the alkenes rather, because the alkenes tend to have double bonds. The hybridization of carbon atom in ethane is, okay, let's look at what hybridization. Hybridization means mixing of orbitals to form a hybrid. Okay, we'll be looking at the S and P orbitals. So now let's look at hybridization of organic compound. So let's start with alkanes, compounds that have single bonds. So for single bonds, they tend to have sp3 orbitals. For compounds that have double bonds, they tend to have sp2 orbitals. While for compounds that have triple bonds, they tend to have sp orbitals. So ethane happens to have triple bonds, so the hybridization is sp. So the answer is D. Now, alkaline hydrolysis of naturally occurring fats and oil yields, the answer is soap and glycerol. So that's option B. So take notes. Alkaline hydrolysis of fats is simply reaction between sodium hydroxide and fatty acids. Okay, fatty acids. Okay, that's okay. Now this reaction. Now when this reaction occurs, the product is soap and glycerol. So now the name of this reaction is called saponification reaction. Saponification reaction. Take notes. When you hear saponification, saponification reaction is a reaction between fatty acids and alkaline or sodium hydroxide to form soap and glycerol. So let's look at the next question. Now, alkanes. So this question is basically testing your knowledge of the alkanes. So for alkanes are all gases? No, this is wrong. They are not all gases. Some are solids, some are liquids, sorry. Now, you have general formula. No, this is not the general formula. The general formula of alkane is CnH2n plus 2. They contain only carbon and hydrogen. Okay, I think this should be the answer. Are usually soluble in water? No, they are not soluble in water. Are usually active? No, they are unreactive, actually. So the answer there is C. They have only carbon and hydrogen. That's why they are called hydrocarbons. Now, the function of concentrated sulfuric acid and the acidification of ethanoic acid with ethanol is to serve as a catalyst. To act as a catalyst. So that's it. So this is a acidification reaction between ethanol and ethanoic acid. Let's look at the next question. A man suspected of being drunk is made to pass his breath into acidified potassium dichromate solution. That's the compound is K2CR2O7. So now, if his breath carries a significant level of ethanol, the final color is going to be green. Okay. Now, the color of this compound, potassium dichromate, is actually orange. Okay. So when you pass ethanol through this compound, the compound will undergo a redox reaction and then it will become green. So let's go to the next question. The process involved in the conversion of an oil into margarine is known as hydrogenation. Okay. So hydrogenation reaction is, for example, you have fats and oil. Okay. And then you actually heat this using NECO catalysts and hydrogen. You react with the hydrogen. It's going to give you margarine. Okay. This reaction that occurs in the presence of hydrogen is called hydrogenation reaction. So it's the conversion of fat and oil to margarine. Let's go to the next question. Which of the following roles does sodium chloride play in soap preparation? Now, this reaction is asking you what is the role of sodium chloride, that's the common salt, in preparation of soap. Okay, that's in saponification reaction. Now, the main function of sodium chloride when it's being added to soap production is to separate the soap from the glycerol. So the sodium chloride makes the soap to precipitate more, makes it insoluble. Okay, so when it is now insoluble, you can now easily take out your soap from the glycerol. So I hope that is clear. So, all right, let's look at this question. When ethanol is heated with excess concentrated sulfuric acid, the ethanol is dehydrated. Remember, this reaction is a very popular reaction. Now, so when you have ethanol, for example, CH3, CH2, and then CH2, OH, and then it is being heated, okay, let's say to a high temperature of, let's say, 180 degrees Celsius in the presence of H2SO4. Now, what happens is that dehydration will occur. This ethanol will be converted to ethene. Okay, so dehydrated to ethene. So that's why C is the answer. So let's look at the next question. So which of the following compound is not formed by the action of chlorine on methane? So the answer is B. Okay, B, because B is an eth compound. The rest are meths. Okay, they have single carbon. They are meths. They have single, but this one has 2 carbons. Okay, so that is why it's wrong. So it can never be a product. So let's go to the next question. Which of the following are made by process of polymerization? So the answer here is nylon and artificial rubber. So these two are made by process of polymerization. Let's look at the next question. Starch can be converted to ethyl alcohol, so by fermentation. So fermentation is a very is a reaction that converts starch, okay, to ethanol. Okay, so we use yeasts. Okay, yeast is a fungi which catalyzes the fermentation process. The next question. So which of the following compounds will give a precipitate with an aqueous ammoniacal solution of copper chloride? Now, so this is test for terminal alkynes, like I said initially. So the only compounds that are able to give a white precipitate with ammoniacal solution of silver nitrate, silver chloride, or copper chloride are usually the alkynes. Okay, the alkynes. That means alkynes are compounds with triple bonds. So our answer here will be B. Okay, and it's also a terminal alkyne. Next question. So when a large hydrocarbon molecules are heated at high temperature in the presence of a catalyst to give smaller molecules, the process is called cracking. Cracking. The answer is C. Now, what is cracking? Cracking is the breakdown or disintegration of large organic molecules. Okay, that means carbons that have long chains. Okay, carbons that have long chains to form carbons that have shorter chains. Now, cracking is a very important process in the petroleum industry because you see this long chain hydrocarbons, they are sometimes not useful in this form. So cracking in the presence of catalyst or temperature would break down these large organic molecules to give us smaller and more useful organic compounds. Now let's go to the next question. The reaction between an organic acid and alcohol in the presence of an acid catalyst is known as esterification. Okay, esterification reaction is the reaction between alkanoic acid, which is an organic acid, and alcohol to give us an ester and water, H2O. So this is more like a repetition of some of the questions we just treated. The IUPAC names of the compounds, this and that, are respectively. So that means now this is a carboxylic acid because of the carboxyl group. So it has two carbon, right? So this is called ethanoic. It's ethanoic because of the presence of two carbons. Now this one also has two carbons, but it has a double bond. So this is an alkyne. So an alkyne called ethene. Sorry, alkene rather. An alkene called ethene. Okay, alkynes are actually triple bonds. Okay, let's not confuse it. So why alkenes have double bonds. So the correct answer to the question is A, ethanoic and ethene. Now the next question. Which of the following is not a member of the homologous series of the paraffins? Okay. Now paraffins are called alkanes. Okay. So if you look at this, for us to say that they belong to the same homologous series, they must all follow or have the general formula CnH2n plus 2. Okay, if you look at this corresponds, okay, this corresponds, this also corresponds, okay, because 2 times 7 is 14 plus 2 will give us 16. So 2 times 15 will give us 13 plus 2 will give us 32. Now, if you look at this E does not correspond because 2 times 24 will give us 48. So this is more like having the general formula CnH2n. Okay, so it does not correspond. So that's why the answer there is E. So let's go to the next question. Now, an example of an alcohol, okay, an alcohol, this is very simple. If you know your functional group very well, so the answer to this question is it is an alcohol because of the hydroxyl group. Number 50. Last. The most common type of chemical reaction which alkane undergo is called substitution reaction. Okay, now I want you to know this. Okay, for all hydrocarbons, that's for alkane. For the alkenes, and then the alkynes. Okay, this is saturated single bonds. This is unsaturated double bond. This is unsaturated as well, triple bonds. Okay, so the three of them undergoes combustion reaction. That's one reaction that all organic compounds undergo. Now, but there are some reactions that are unique or peculiar to each of these. So for the alkanes, it's a substitution reaction. For the alkenes and the alkynes, both of them undergo addition. Both of them undergo addition reaction. But the alkene, the reaction peculiar to the alkene is polymerization reaction. They undergo polymerization. That means they form polymer. Okay, so that's for that. So I hope you enjoyed this video. Ensure to subscribe and like and also share.